We want to find the volume of the solid obtained by rotating the region bounded by y equals sine 2x squared and the x-axis on the closed interval from 0 to the square root of pi divided by 2 about the y-axis. So this shaded region here is the bounded region. If we rotate this about the y-axis, it would give us this solid here. Our goal is to find the volume of this solid. One more thing to mention, when x equals the square root of pi divided by 2, the point would be right here, our x-intercept. Notice how if we substitute this value for x into our function, we'd have sine pi, which is equal to 0. So because we have a function of x and rotation about a vertical axis, we'll be using the shell method, and therefore we can find the volume using this formula here, where the volume equals 2 pi times the integral of p of x times h of x integrated with respect to x from a to b, where p of x would be the distance from the axis of rotation and h of x would be the height of any shell. To help us set up this integral, we'll sketch a representative rectangle that when rotated about the y-axis would give us one shell of the volume of the solid. So for example, if we use this rectangle here and rotate this about the y-axis, it would give us one shell of the volume. To help illustrate this, we could use these shells here to approximate the volume of the solid. Notice as the number of shells increases, the volume of the shells would approach the volume of the solid. So if we take the limit as n approaches infinity of the sum of these volumes, this is what gives us our definite integral. Looking at this rectangle, notice how the width would be delta x, which is the reason why we integrate with respect to x. And this distance here, the distance from the axis of rotation would be p of x, which is just the x value. So we can say p of x equals x. And then the height of this rectangle, which would represent the height of a shell, would be this distance here, this length, which is given by the function value y equals sine 2x squared. So h of x equals sine 2x squared. And the interval again is from 0 to the square root of pi divided by 2. And now we can set up the integral to find the volume. The volume equals 2 pi times the integral of p of x, which is x, times h of x, which is sine 2x squared, integrated with respect to x from 0 to the square root of pi divided by 2. Let's evaluate this on the next slide. We'll have to evaluate this using u substitution. Notice how if we let u equal 2x squared, differential u would be a linear function involving x. So we'll let u equal 2x squared, and therefore differential u is equal to 4x dx. Notice how our integrand has x dx. So let's solve this for x by dividing both sides by 4. So we have 1/4 du equals x dx. Now let's write this in terms of u. We'd have the volume equals 2 pi times the integral. Now we'll have to rewrite the limits of integration for u. Right now they're in terms of x. So if u equals 2x squared, notice when x is 0, u is still 0. But then when x equals the square root of pi over 2, we'd have u equals 2 times the square root of pi over 2 squared, which would be 2 times pi over 2, or just pi. So the upper limit of integration in terms of u would just be pi. And then 2x squared equals u, so we have sine u. And then x dx is equal to 1/4 du. Let's go ahead and factor out the 1/4. And then we have du. So let's simplify this. This would be pi over 2 times the integral from 0 to pi of sine u, integrated with respect to u. Well, the antiderivative of sine u would be negative cosine u. So we have pi over 2 negative cosine u. So we have pi over 2 times, well, cosine pi would be negative 1, but we also have a negative sign here, so we have negative negative 1, or the opposite of negative 1, minus cosine 0 would be 1, so we'd have minus and then a negative 1. So this ends up being pi over 2 times, this is 1 plus 1 or 2, and therefore the exact volume is pi cubic units, which would be approximately 3.1416 cubic units. So if we go back to the first slide, if we rotate this bounded region about the y-axis, it produces this solid, which has a volume of exactly pi cubic units, which we found using the shell method. I hope you found this helpful.